In this demonstration we're going to look at some of the basic commands within NX Sheet Metal, and to do that we're going to design a tray. We're starting off with this guide block as our designing context, but before we get started let's have a look at the material properties that we've got set up here. I'm using a value entry for my global parameters, and we're going to start with a 3mm material thickness and a 3mm bend radius. So let's get started with the design that's shown in the top right corner there. So to begin with, what I can actually do, I can create the main structure of this design just by generating a tab on the bottom face, and then a flange and another flange and so on. But what I'm going to do here, I'm going to use the multi-bend reference capability of the tab command. So rather than go straight ahead and draw a sketch and then add further features there, we're going to expand the multi-bend reference group, and I'm going to specify my additional planes first. And let's just see what's going on so we can expand this list here. So I'm going to pick this face here as my first reference, and then I'm going to add this top face as a second reference. So I add a new set, and the parent of this top face is the one that I've just created. So I just change my parent to be plane 1, and I select my top face. So I've now got two references, plane 1 and plane 2, and I can now go ahead and generate my sketch on this bottom face here. So we go into the sketch section, we pick this surface, but I want to move my origin to the center just so that we can do something that's easily symmetrical. Into sketch mode, and the first thing you'll notice is between my references, and if I just hide the guide block for now, you can see the reference faces that I've selected are shown here in the sketch, along with the bend center and bend tangent lines that are represented by the intersections between these faces here. So I can now continue and sketch my overall flat profile that's going to be generating into the three parts of the bend of the part. So I start with my my sketch, and I want to pick up on this top edge as my reference, so I include that as a reference point, pick up on it, and draw my rectangle for my base part. So I just want to add some dimensions here. I'm going to add a dimension across the width, and I'm going to make this 70. But what I want to do is to make this symmetrical. So if I select both edges and the center line, I can use the make symmetric, and notice there's a shortcut S which I could do very quickly, but I'm going to click that there and make it select symmetrical. And there's a warning here that's telling me that some curves that I've already constrained are going to move, and that's okay. I'm now going to put in a dimension to the bottom of this of 20, and effectively I've finished my layout. Everything else is constrained, my curves have gone black, and if I finish this, we can actually see what has happened here. So if I turn my guide block back on again, we can see that I've got my sketch, I've got my first reference plane, and my second reference plane. It's made an inference of the direction, not quite what I was expecting, so I go back to my specified plane and I flip that around, and then we can see that it goes in the right direction. But we're still not correct here, we're inside the block. So I want to make this material outside. And just to be complete for tolerances, I'm going to give it a 0.5 mm clearance. So we've now got what we were after. Now I could finish here and continue, but I'm going to go back into the sketch and add a few more references here. These two holes that I've got coming through here, I want to make some clearance holes for. So I'm going to use my offset command and pick up on these curves. Again, I need to include those in the sketch. And one thing I'm going to do with offset curve, I'm going to make these persistent relations such that I can adjust them later. So I'm going to pick up on these two curves, and I'm going to give them a 0.5 mm clearance. I'm going to add one more feature to this sketch here, and I'm going to put a rectangular cutout at the bottom. Again, remember the make symmetric. Select the two edges, select the center and hit S. That's now in the center. And let's just zoom in on here, and I'm going to give this a width of 15. I'm going to make it 15 from this curve, and I'm going to make it a height of 50. Now I believe we've finished our first sketch and our first feature, and we've got the basics of our design as we go forward. Let's just take away the guide block so we can have a look at the design that we've got there. Now we need to give this some structure, so we're going to add some flanges to the side here. I just start my flange command, and I can pick these as multiple references and control them together. I can control their angle, I can control their length, and I can control their offset. I can add more to this, and they can even go in a different direction, but I don't actually need to do that for this. I'm going to keep this very simple. The length is going to be 20, the angle is going to be 90, and I'm going to have a 0 offset, just to keep things nice and simple. Now I need to tie these side flanges into this back face, and if I just flip this over, and we'll focus on this corner here. So I'm going to use the close corner command, and I'm going to pick these two faces, and it generates me a corner here. Now I can go in now and adjust the actual properties I need here. Now what I like to do here is to use the U cutout with mitre, and I'm going to put its origin on the corner point. And what we've done here is created a very clean cutaway and clearance, but I'm going to make that diameter of that clearance much smaller here, and it generates something that looks like a closed corner, but it is in fact a U shape here with a little bit of a gap there. I can generate a gap down, but I'm not going to do that for this. Now I can either OK this and repeat it on the other side, but what you can do with closed corner is just pick two more faces, and we can generate the corner on both sides simultaneously within a single feature. So I've effectively got a relatively complex design generated within 3 features. Let's go on to the next part of the design, where I'm going to remove some of the material down these side flanges, and I've generated a sketch which I'm going to show here, and just cut away these at an angle. So for this I'm going to use the normal cutout command. I'm going to change my selection criteria to be single curve and just pick this bottom edge here. I'm going to change my limit to be through all and symmetric depth, and we can see the normal cutout is honouring the perpendicularity of the thickness faces as it starts to bend round this corner. And I'm getting close to finishing my design. So at this point what I'm going to do is to create a flat pattern and have a discussion with my manufacturing team and get some feedback and review on my design. So let's create the flat pattern. I'm actually going to use an orientation 90 degrees from the default just for simplistic viewing. Just makes it nice and tidy for this demonstration. I'm going to create a new window, and in this new window look at the flat pattern which I've got here, and then just drop that side by side so we can see the 3D part of the design and the 2D flat pattern. I'm just going to, for now, just pull these bend labels out the way, and we can see our flat pattern. So with discussion from my manufacturing team, they can't make these bends that run out to 0. The material isn't supported and it's going to deform. So the first thing I need to do is to add some material here before the bend is created, such that it can be removed later downstream. And the way we do that is we edit this normal cutout feature. And what I've actually done here, let's just bias the screen a little bit here. I'm going to remove this selection, and I'm going to turn on stop at intersection because I've got a couple of extra curves here. and I'm going to generate a cutout that looks something like this. This puts material back such that the bend can be generated without any distortion. But to do that, what I need to do is to fix the flat pattern at timestamp and then add a feature after the flat pattern to remove that extra material. Now this would be ground off or cut off in the general way, so I'm just going to use an extrude. I'm going to use a single curve again from this same sketch, and I'm going to make this a symmetric, and then just make that open profile, pick the correct direction and chop those edges off. But what you can see here, my final design is as expected, as I wanted it, and my flat pattern is that the manufacturing team need it. So we've got this extra material here, they can do the bend, and then we can cut this off later. The next comment is the material is a little bit heavy and we need to make it thinner. And I've also been asked to use one of the preferred materials that's been created. So if I go back into my part properties tab here and I change my value entry to material selection, I can go and look at my predefined material list here. Now I've been asked to make this 3mm thinner, so I'm going to select a 2mm and put some strengthening features in a while, just to beef up the strength of this part. I'm going to use a T4 grade, and we're going to select one of these two materials. Now what I'm going to do, again for demonstration purposes, I've got a material here that drives the bend radius and neutral factor from a tool table. What that means is when the design is created, the tooling that's used is defined and generates the bend radius. So if you think of air bending in sheet metal in straight break, as you bend the material down through the V, the bend radius changes until it bottoms out as a complete 90 degree. So that means bends that are less than 90 degree from the flat are going to have a different radius. So I define my punch and die based on that information. I OK that, and if you look at these radii values here, there are 3 on the flat pattern. What's actually going to happen here for those that are and the look up from my die, you can see my 90 degree angles are actually a smaller radius. The open ones are still 3, and the 90 degree have changed to 2.48. And this is driven from the lookup table. So now I can go back to my design and continue. I need to now strengthen up this design because of the removal of reduction in material thickness. I'm going to hide that now, and what I'm going to do is I've just created a couple of sketches here. I'm going to run some bead deform features through here. What we can do is pick the bead, pick these sketch lines. I can do both at the same time here. Make sure the direction is in the right way, and we can see that when the bead gets to a bend, it just washes out through as it would do in normal tooling. Now I do have a warning here that's telling me that the bead is deeper than the bend radius, so bending might be a bit of a problem. I'm going to change these values anyway. The alert has gone away and I've still got my strength. So I have my beads, and I'm now going to add a gusset feature in the center. I pick the bend, I define the location from the plane, and then we've got a strengthening feature in here. Now I can change the form from square to round. I can change the depth from 10 to something smaller. I'm just going to have a very small gusset in the bottom here. I can change the die radius, for example. And I can finish the feature there. Now for this design, I just need some small holes in these channels. It's very simply just create the hole. I've already created the center points for the holes with this sketch. So I'm just going to pick them. I'm going to change the value to 2 millimeters, and the depth through body and generate those holes. So I'm pretty close to the completion of my design. I'm just going to break a few corners here. Now what I've seen a lot of people do is zoom all the way in so they can pick these small edges. You don't actually need to do that in NX. You can just Windows select and pick up on small edges without having to go into the detail there. And I could continue there, but I've created those. So now back to my manufacturing review. We've got a few things we need to change here because all of those extra features I've now added are not showing up on the flat pattern. So what we're going to do here, I'm going to take my bead, my gusset and my holes and break corner and just drag them before the flat pattern. And we can see those features arrive on the flat pattern, and we can now go back for our second review. So we've got our deforms, we've got our holes. Now the next part of this review is telling me that these holes are too small for the laser cut to actually generate them. And the way we do that, we can either go into the sheet metal preferences, flat pattern treatments and change it here, or we could actually change it individually in the feature. But I'm going to change it in the preferences, and I'm going to say any hole is replaced with a center mark that is less than or equal to 2 times the material thickness. So I can actually control this with this variable, so any hole that's 4 millimeters or less will be replaced by a center mark. And when I OK that, we can see that these holes on the flat pattern will be replaced with center marks, like so. The other request is to have a break corner here to make the laser cut a little bit more realistic. So I'm just going to go into my break corner and select these two, and that appears on the flat pattern as well. And one more thing I need to add here, I'm just going to break the corner on this front edge. Again, leave that at the end because it's after the extrude that creates the cut. And we're pretty well much complete there. Let's have a look at the flat pattern, because this contains some properties in terms of the exterior and interior cut lengths, which is a guide to the, if you understand the cost of laser cutting in terms of the time it takes to do a cut length, you can get some very broad cost estimate here. And we can also see our material usage, the minimum X and Y dimensions for the blank on the flat pattern. So if we now have pretty well much completed our design, but if we go back to our guide block, and we can see that we've designed this bracket in context with this guide block. And the real value and beauty of designing in context here, if this guide block is to change, so if I edit the parameters of this guide block, for example, and we have a look at, say, this 105-degree angle, let's say this changes to 110. We can see the guide block change, and when that's okayed here, we can actually see that our bracket follows that new profile. The flat pattern's updated. If I just do an undo, you can see the change as it jumps back. And we can see everything's updated and in context. So let's move on to the next stage in our design. We're going to create a drawing view for the flat pattern. We switch to drafting. And we generate a drawing. Now I could generate all of the top, all the orthogonal views and so on, but I'm just going to do, for this demonstration, just show the flat pattern view. Drop that on the drawing there, and we can see our pre-configured bend labels have also been generated. And then I can come to my bend table, pick the view, and generate the bend table data as well. Now, if you want to change the order, the ID of each one of these bends, if we go back into the flat pattern view, and we can see that this is the first one, this is the second one. If we wanted to swap these over, we can go into our bend list and just take bend 2 and move it up. And if you look at these two numbers here, when I OK the dialog, we can see they swap those. So very easily we can switch that about. So back into our drawing, we've got our view. If we just update that, we can see that we've got our bend sequence numbers have changed here. And I'm going to add one more bit of information. We're driving or creating this part from the material table. So I'm going to add a note here, which is material. And if I go to my part attributes and scroll down to my sheet metal material table attributes, we can see the bend radius, the drawing name, and material name are all available to us, and I can drop that material in there as a note or in a material box, however your format is set up. And if that material spec should change in the part, it'll automatically update on the drawing. Okay, so what we've actually been through here, we've been through the capabilities of multi-bend and multi-profile tabs. We've had the multi-flange, we've looked at closed corner, normal cutout, and some of the capabilities in the flat pattern feature. We've been through break corner, we've done bead and gusset deform features. We've shown the capability of removing small features or holes from the flat pattern, and we've shown the combination of sheet metal features along with modeling features just to cut these bottom edges off. So I hope this overview has been of some use to you, and come back again for more videos.